see how that changed color after I added some carbon dioxide to it? What's going on there? What did the carbon dioxide do? Why did it change color? Alright, I've changed the pH of this solution. And there's an indicator in there that's telling me that. And that's what we're going to talk about today. Here, title today's pH. In a neutral solution, okay, so in a neutral solution, the hydrogen ions and the hydroxide ions are equal in concentration. In an acidic solution, the hydrogen ion concentration is greater than the hydroxide ion concentration. And in a basic solution, the hydrogen ion concentration is less than the hydroxide ion concentration. So we use the pH scale to represent how acidic, or conversely, if we want to think about it in the opposite way, how basic a solution is. So the pH scale is used to describe solution acidity. So the pH scale is used to describe how acidic a solution is. pH is a logarithmic, log scale. Okay, and so what does this actually mean, pH? Well, pH equals the negative log of the hydrogen ion concentration of a solution. So, P actually means the negative log of, because if you take the log of hydrogen ion in a solution, it's going to come out to be a negative number, and so you're going to take the opposite of that, and that will be the solution's pH. Okay, so what pH measures really is how much hydrogen ion we have in a particular solution. And so, if I was you, I would take out your calculator right now. So if the hydrogen ion concentration of a particular solution is equal to 1.0 times 10 to the minus 7th molar, what is the pH of that? Well, what do? We take the log of 1.0 times 10 to the minus 7th, and that will give us minus 7, and then we want the opposite of that. is 7. So that means in this situation, pH is equal to 7. I would try it if I was you right now on your calculator at home. The log of this number and the opposite of it is a positive 7. Okay, now, what if we go the other way around? What if we say if pH is equal to 3.8, what is the hydrogen ion concentration? Okay, so if we're given pH, how do we find the hydrogen ion concentration? So, what we do is we say 10 to the negative pH, which in this case is going to be 10 to the negative 3.8. So try that on your calculator and see what you get. The hydrogen ion concentration should be equal to 1.6 times 10 to the minus 4th molar. It's real important that you're able to do these things. So if you are given the hydrogen ion concentration, can you convert that to pH? And if you're given a pH, can you convert that to the hydrogen ion concentration? All right. Now, pH is a logarithmic scale. So that means every value of 1 on the pH scale has a magnitude of 10 times that above or below it. It's like the Richter scale for magnitudes of earthquakes. Okay, so a solution of pH 3 has 10 times the hydrogen ion concentration as pH 4, and how many times compared to pH 5? 100 times the H plus as pH 5. Okay, now the interesting thing about the pH scale is that the lower you go, the greater the hydrogen ion concentration. So, pH 6 is slightly acidic, pH 5 is more acidic, pH 4 is more acidic. So, as your pH goes down, your hydrogen ion concentration is going up. Okay. Now, essentially, the pH scale goes from 0 to 14. 7 is neutral. Anything above 7 we say is basic. So if the pH is between 7, well, above 7 and below 14, this whole range is basic, and no, stop. Okay, And anything below 7, so 7 to 0, but below at 6.99, we say is acidic. Below, the hydrogen ion concentration is greater than the hydroxide. Above, the hydrogen ion concentration is less than the hydroxide. And here at 7 neutral, the hydrogen ion and hydroxide ion concentrations are equal in solution. Okay, for any aqueous solution, at 25 degrees Celsius, pH plus pOH is always equal to 14. And that is going to be a handy tool for you to use. Okay. What other little things do we need to cover here? Okay, let's do a little problem. And then we've got one more thing to address, and we will be done with our overview of pH. All right, clear the page. So let's do a problem. The pH of a sample of human blood was measured to be 7.41 at 25 degrees Celsius. Okay, that is a perfect pH level for human blood. Anywhere between 7.35 and 7.45 is normal for a human. So the pH of a sample of human blood was measured to be 7.41 at 25 degrees Celsius. I'm going to try a different pen. Oh no, this is the one that's not supposed to squeak. Okay, sorry guys. Calculate. The pOH, the hydrogen ion concentration, and the hydroxide ion concentration for the sample. Okay, so what do you suppose, I didn't even say anything about this, what do you suppose the pOH is? The negative log of the hydroxide ion concentration in the solution. P always means the same thing, the negative log of. Alright, so to find the pOH, I'm given the pH, so I am going to say 14, do it over here, minus 7.41 is going to be equal to my pOH. And I've got my pOH, and so it's going to be very easy for me to figure out both of those concentrations. So my hydrogen ion, H plus, is equal to 10 to the negative 7.41, and my hydroxide is equal to 10 to the negative 6.59. So you guys work these out and tell me what the molarity or the concentration of each of those things is. Tomorrow, I will look for them in your notes. All right, last but not least, let's get back to what I did at the very, very beginning when I was blowing bubbles, doing exactly what you're not supposed to do in a restaurant. How do we measure pH? How is pH measured? Okay, and there's a few different ways that we can do it. If we want to do it in kind of a general fashion, not to the 100th place in terms of decimal places, generally, with a little bit greater of a source of error, we use litmus paper and chemical indicators. Okay, and actually litmus paper does have a chemical indicator embedded in it. But precisely, what do we use? That doesn't look. I think there's an A. We use a pH meter, which we will use in class, which has a digital readout that gives you the pH value to the nearest 100. Okay, so you have used an indicator before. When we did the titration of sodium hydroxide and hydrochloric acid to figure out the concentration of the hydrochloric acid, we used an indicator that went from clear to pink as soon as the pH went a little above 7. Do you remember what the name of that indicator was? That indicator was phenolphthalein. And that's it.